Recall that absolute values represent distance, and when we're trying to solve the absolute value of x equal to 8, we're saying find those values of x whose distance is 8 units away from 0 on the number line. And that basically tells us that x will equal -8 or x will equal +8. And in this case we would use a plus or minus symbol. X is equal to plus or minus 8. Now, when we're solving absolute value equations, it's important that the absolute value is isolated by itself on the left, as we have in both of these examples. On this next problem, I want to say x plus 5 is either equal to -3 or x plus 5 is equal to +3. Try not to use the plus or minus notation until the very end of the problem. Subtracting 5 on both sides, we will have -8, or subtracting 5 on both sides, we will have -2. I'm going to write this with a comma, -8, comma, -2 as the solution set, or sometimes we write this using a solution set notation. In this third example, we need to isolate the absolute value by itself before we remove the absolute value. So I will begin by subtracting 4 on both sides. This gives us the absolute value of w is equal to -12. Well, distance is always positive, and whenever you have an absolute value equal to a negative, right off the bat, that makes no sense, and our solution is the null set or the empty set. So be on the lookout for negatives when you have absolute values involved. Okay, true to pattern here, let's write 4x plus 1 equals -6, or 4x plus 1 is equal to +6. In both of these equations, we will be subtracting 1 on each side of the equation, and so we will either have 4x equals -7, or 4x is equal to 5. Therefore, x will equal -7/4, or x will equal 5/4, and I will write that as the solution set, -7/4 and 5/4. Okay, again, let's isolate the absolute value by itself by adding 2 to each side of this equation. This will give us w over 2 plus 3/2 is equal to, let me put that in absolute values, is equal to 9. And then we can remove this absolute value and write w over 2 plus 3/2 is equal to -9, or w over 2 plus 3/2 is equal to +9. In both of these cases, I would clear the fractions right off the bat by multiplying each side by 2. This will give us w plus 3 equals -18, or w plus 3 is equal to +18, and subtracting 3 from each side of each equation, we have w equals -21, or w is equal to 15. So I will write that again as a solution set. Those are the two values that can be substituted back into this equation to make it make sense. Okay, now we have a little bit trickier of a problem with absolute values on each side. Basically, well, this is how we're going to solve it. We're going to say 9a plus 5 equals the 9a minus 1, as if there are no absolute values at all. Now, this actually works in case both of these are positive, in which case the absolute values aren't needed, or the insides of each are negative, in which case both sides are made positive and no absolute values are needed there. But there's another case we want to look at, and that's what if the sign of the expressions inside the absolute values are opposite? So what we would do then is we would say 9a plus 5 is the opposite of, use a minus sign and a parentheses, the right-hand side, 9a minus 1. And we would solve these two equations. For this first one, however, when I subtract 9a on each side, I get 5 is equal to -1, which makes no sense, and so there's no solution on this first part, and so I have no solution or whatever's on the right. So let's look at what's on the right. I'm going to do some distribution. We will have 9a plus 5 equals -9a plus 1. Get all of the variables to one side, so I will add 9a to each side. This will give me 18a plus 5 is equal to 1. I would then subtract 5 on each side to have 18a is equal to -4, and divide each side by 18, and that will give me -2/9 after I reduce that fraction. So we just have one value of a that solves this absolute value equation. Let's try this again. 3p plus 2 over 4 equals 1/2 p minus 2. That's if the sign inside both absolute values is the same, or they're opposites of each other, in which case I would write 3p plus 2 over 4 equals the opposite of this right-hand side, 1/2 p minus 2, being very careful to use the parentheses on the right. On the left, let me split this up with a little wall there. On the left, I'm going to multiply by 4, which is the least common denominator, to clear the fractions. Multiplying by 4 will clear out the fraction and just give me 3p plus 2. And on the right, a half times 4 is 2, so I'm going to have 2p minus 8 after the distribution. I will then subtract 2p on each side and have p plus 2 equals -8. Subtracting 2 gives me p equals -10. Or, let's see what's going to happen on the right-hand side. We will have some distribution. So that is 3p plus 2 over 4 equals -1/2 p plus 2. Again, I would multiply through by 4 to clear the fractions. The left side becomes 3p plus 2 equals the right side, which is -2p plus 8. I'm going to then add 2p to each side, and while I'm at it, I will subtract 2 on each side, and that will give me 5p is equal to 6, and p is equal to then 6/5. So our solution set for this problem is the two values -10 and 6/5, both of which will check if you substitute it up into the original equation.